Back at the blackboard, I'll sketch what happened, with the check-in that caused the problem represented as a red line that flows through to John's working copy. Note that as far as Mike is concerned, all is well with the world, while John's working copy is broken. As it stands, this picture doesn't seem like an especially bad problem, because John can be sure when he inherits a breakage after doing a subversion update that Mike was the cause. But what if more people were involved? What if 4 or 5 other people had committed changes before John did his update? John knows that something was wrong with one of those check-ins, but not which one specifically, so he has to go on a hunt to find out, potentially debugging all kinds of unfamiliar code, and then inform the originating developer so they can fix it. This scenario is an especially annoying way to develop software, and can cause disharmony on teams, as you open up the possibility of that software development classic, "Well, John, it works on my machine." Continuous integration helps get around this "it works on my machine" problem by setting up an automated team member whose single responsibility is to check out every check-in and make sure it compiles and passes its tests and can be deployed. It does this as soon as a check-in is made, so problems are caught early, while they're still fresh in the minds of those who introduced them. Because it's an automated team member, a machine in other words, it has an independent, impartial view, so any temptation we may have to say, "it works on my machine," is pretty much eliminated. It works like this. Set up a build server that represents the automated team member. The build server monitors for check-ins to the source code control server. When it finds one, it checks out the code, compiles it, tests it, and makes whatever other kinds of checks we've configured it to do. At the end, it produces a report. Notifications of build breakages can be issued in all kinds of imaginative ways. Sending emails, sys-tray notifications, making big, highly visible screens red, changing the color of lava lamps, electrocuting people. That's my favorite, electrocuting people. The point here is that in this case, when Mike checked in a broken test, the build server identified it very soon afterwards, and there was no doubt that Mike's check-in introduced the problem. Usually this means that on receipt of notification from the build server, in whatever form it comes, Mike will go ahead and fix the problem before other team members waste time checking out what went wrong and who was responsible. So the real benefit of continuous integration is that we are always aware of the health of the software checked into subversion, and when it's unhealthy, we get a chance to act on it early. As with source code control, there are many options to choose from when it comes to build servers. I'm going to avoid that discussion entirely and just go with JetBrains TeamCity. It comes in 2 flavors. Professional is free and supports up to 20 builds, I think. And Enterprise is not free and is pretty much unlimited in terms of number of projects. Choose a directory to install TeamCity in. I'm going to put it in Tools. Decompress the gzip archive, then untar the tar archive. This will create a TeamCity directory for you. There are several subdirectories and files in here, but we'll ignore them for now and just go and see what's in the bin directory. Again, lots of files, some of which are part of a Tomcat installation, judging by the Catalina word, but we'll focus just on the TeamCity server shell script. On Windows, you'll use the .bat file. If we run the script, it tells us that it expects to be told whether to start or stop the server. Let's start it and see what happens. It logs to a directory above us. Here you can see a mixture of standard Tomcat log files and some TeamCity specific log files. Let's see what TeamCity has to say for itself. Lots of stuff scrolling by, but I can just about make out the magic words "server started," about 5 lines from the bottom. That should mean we have something to look at in our web browser. TeamCity listens on port 8111, and because this is the first time through, we have to accept the license agreement. The server requires a username and password. I'm just going to use TeamCity for both for the sake of this demo, but you may make the decision on your team to use personal IDs so you can track who did what to the server. The next step is to tell TeamCity about our project. First we state what the name is, Hello World. Then we tell it how to build the project by adding a build configuration. What's the difference between a project and a build configuration, you may ask? In TeamCity terms, a project really isn't much more than a name. Each project can have one or more build configurations, and each build configuration expresses what we want to build and how we want to test it. You may have one build configuration for unit tests, which runs very quickly and gives you early warning of build breakages. You may have another that runs your integration tests and might be a little bit slower, and a third that runs your acceptance tests and is slower still. We've really only got one build configuration suggesting itself at the moment. We're just going to build trunk. The rest of the settings can be left defaulted for now, and we can move on to telling it about our source code control server. The first thing we have to do is define where our server is located by creating and attaching a VCS route. As mentioned earlier, there are many source code control systems out there, so we start by telling TeamCity which one we're using, Subversion. After a second or two, TeamCity updates the page, ready to take all the Subversion-specific details. We give our VCS route a name. Hello World Trunk seems pretty descriptive, and then we enter the Subversion repository URL, which hopefully will look familiar from the import into Subversion. You may need a username and password, but that will be the same as what you used when doing the Subversion import. Test the connection. If you get errors, hopefully TeamCity will give you good descriptions of what went wrong, but the first couple of things to look at would be the Subversion URL. Is it correct? And do you need to enter a username and password? And are they correct? In my case, the connection has been successful, so I can move on. We get confirmation that the VCS route has been created, so we can go to the next step. Now we have to say what tool we're using to build our project. We're using Ant, which is the default, but as you can see, there are many possibilities. We get a chance to say what the name of our Ant file is, and again we're in line with the default of build.xml, so all that remains for us to do is state what Ant target we'd like run for us. The only sensible one we have at the minute is Ant war. The rest of the settings here are fine at their defaults for what we want to do. We may come back to some of them as our needs get more sophisticated, but until that time we confirm what we've got. Confirmation that the trunk build configuration was saved is presented at the top, and a run button has appeared towards the right. I can never resist pressing a run button. Never. Oh, do I love run buttons. Let's see what happens. We get a warning saying that there are no agents capable of running this build configuration. Let's step out of this for a minute and talk about agents. This TeamCity process that we've been interacting with in Firefox for the last couple of minutes is the TeamCity server. It's a central process that knows about what we want to build, what Subversion repository, what Ant target to call, and so on. The build configuration. When it comes to actually running a build, the server delegates the work to another process, and this process is called an agent. It's the agent that does the work of compiling and testing our code under the instruction of the server. It's a two-way conversation as the agent updates the server on progress and the final result. There can be any number of agents running on any number of machines on our network, allowing us to assemble what's known as a build farm. You can scale the build farm to the size that your particular project needs, within reason.